Good morning, one and all. I am Dr. Ramya Swetha from Civil Engineering Department. Today our topic is classification of turbines. Coming to the classification of turbines, it is the how we are classifying, we are identifying the turbines under various parameters. So based on the parameter, which we are considering, whether it is maybe head, whether it is maybe specific gravity, whether it is maybe working principle of that particular turbine, and the way of enter the water, the flow, how it enters into the turbine based on the rotation of the turbine. Like these all these are all the based on all these parameters we are going to categorize these turbines. So this is our today's topic. So based on that, how we are classifying the turbines. So coming to these classification of turbines, these are the some of the web references which are going to enhance the it gives the better understanding and enhance the knowledge. So we these websites, these are the some of the web references which are very helpful for us enhancing the knowledge on these particular turbines, and they're based on their parameters how we are classifying. So coming to this topic, first we have to understand what is a turbine. Turbine, it is a it is a machine which converts the energy. So these turbines converts hydraulic energy into mechanical energy. So it is converted into a in its transfers that kinetic energy and potential energy of water into a rotation. In this, coming to the hydraulic turbines, they are going to transfer kinetic energy and potential energy of water into a rotation. We using these turbines, we are going to generate the electricity by coupling to electrical generator. We are going to generate the electricity by using turbines. So these machineries are helpful conversion of energy. One form of energy is converted into another form of energy. And so in these are the turbines. Coming to the classifications are based on in different ways. So based on flow path, based on working principle, according to the head and inlet of the turbine, according to the specific speed. So these are the various ways for understanding the and categorize these turbines. So based on the flow path, based on the working principle, based on the head, based on the specific speed. These are the some of the parameters. These are the some of the parameters which we are using. Parameters which we are using for conservation of energy. Conservation of the turbine. So in these classifications of hydraulic turbine based on the flow path, classifications of turbine into axial flow, radial flow, tangential flow and mixed flow. Based on the flow, so axial flow, radial flow, tangential flow, mixed flow. Like this, we are going to categorize the flow based on the classifications of hydraulic turbines based on flow. So coming to the axial flow hydraulic turbines, flow path of the liquid mainly parallel to the axis of the rotation. So whenever the rotation is happened in so many ways, the rotation may happen in so many ways. So the rotation is like this and our rotation is like that, whatever it may be. So based on the rotation, so whenever the flow path which is parallel to the rotation, such type of flow is known as axial flow hydraulic turbine. For this, one of the best example for axial flow hydraulic turbine is Kaplan turbine. Kaplan turbine is in this Kaplan turbine, how the flow path is, which direction the flow path is there, the rotation is also in that is parallel. So those kind of turbines is known as axial flow turbines. So this is the one of the example for axial flow hydraulic turbines. Coming to the radial flow hydraulic turbines, liquid flowing mainly in a plane perpendicular to the axis of the rotation. So liquid flowing mainly in plane perpendicular to the axis of rotation. Whenever the axis of the rotation, which is the flow path is perpendicular to the rotation. This is flow. This is the path of rotation. For example, this is the path of rotation. This is the flow path. Both are perpendicular to each other. Such type of flow is known as radial flow hydraulic turbine. The next one is tangential flow hydraulic turbine. So in this, liquid flowing mainly in a plane tangential to the turbine. So whenever the liquid flow which is tangential to the turbine, such type of flow is known as tangential flow turbine. One of the best example for tangential flow is Pelton wheel or Pelton turbine. Pelton wheel or Pelton turbine. Pelton wheel is the best one of the example for tangential flow turbines. Similarly, mixed flow turbines. For most of the hydraulic turbines used, there is a significant component of both axial and radial flows. Both axial and radial flows, they are called mixed flow turbines. So it means whenever the water enters into some one x direction and exists in another direction. So whenever the water enter into the turbine like this and exists like this, so such type of combination is there in turbines. So those turbines are known as mixed flow turbines. So coming to these mixed flow turbines, Francis turbine is an example of mixed flow type. In Francis turbine, water enters in radial direction, exists in axial direction. In Francis turbine, the water enters, the entry of flow is radial. The entry of flow is radial and the exit of flow is axial. The entry of flow is radial, the exit of flow direction, mainly the direction. The entry of the flow direction is radial and the exit of the flow direction is axial. So such types of flow of turbines is known as mixed flow hydraulic turbines. For this, Francis turbine is the example, one of the best example for mixed flow turbines. So like this, these four are the categorized based on the flow. So whenever the rotation of the turbine is axial, parallel to the flow entering, so such type is known as axial. Whenever it is perpendicular to the axis of the rotation, such type of is known as radial. Coming to the whenever it is tangential, such is known as tangential flow. So whenever the water enters in the direction, whether it is radial or sometimes the enter into the axial and it may exist into the radial or vice versa, such types of flows are known as mixed flows. Francis turbine is the one of the example for mixed flow. In this, the water enters in radial and exists in axial direction. So this is the one of the way categorizing the turbines. And the next one is based on working principle. Based on the working principle, turbines are classified into two types. The one is impulse, other one is reaction. The one is impulse and the other one is reaction. So impulse turbine, one and only example, that is Pelton wheel. Pelton wheel is the or Pelton turbine. Pelton wheel or Pelton turbine is one of the example for impulse turbine. Coming to the reaction turbine, Kaplan turbine, Francis turbine, Kaplan, Francis, these are etc. These are all example for reaction turbine. Coming to the impulse turbine, the pressure of the liquid does not change while flowing through the rotor of the machine. So in this, the pressure liquid does not change the flowing through the rotor of the machine. So pressure change occur only in the nozzles of the machine. So in this turbine, the working principle is pressure change occur only in the nozzles of the machine. And the energy to rotate an impulse turbine is derived from the kinetic energy of the fluid flowing through the nozzles. So this is the principle which is involved in impulse turbine. Coming to this is impulse turbine. So this is the working principle which is involved in impulse turbine. Coming to according to the head at the inlet of the turbine based on the head. Such types of turbines based on the head: high head, medium head, low head. So based on the the category is, we are getting this type of category, that is high head turbine, medium head turbine and low head turbine. Coming to the specific speed, based on that specific speed, low specific speed turbine, medium specific speed turbine and high specific speed turbine. Like this, the classifications of turbines are happened, that is based on the flow and based on the principle, based on the head and based on the specific speed. Based on these four parameters, we are going to categorize the turbines. In these four different types, in these two different types, in these three different types, again in these also three. In these three, low, high, medium. Similarly, specific speed also low, high, medium. Coming to the flow, axial, radial and mixed, tangential. Coming to the principle, impulse based on the impulse turbine and reaction turbines. So like this, we are going to categorize the turbines, and these turbines are convert the hydraulic energy into mechanical energy, that is, it is converted into a hydroelectric. For hydroelectric generators, we are using these machineries. These are very helpful in irrigation. These turbines are very helpful in generation of electrical power. So we understand various ways. The categories are, we understand in all these ways. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.